Robots. The very word conjures up images of science fiction movies and visions of the future. But could the ancients have created automatic, programmable machines hundreds and even thousands of years ago? Full-size human replicants, animals that moved by themselves, sophisticated multi-action robotic chronometers over 50 feet high. Now, new evidence suggests that ancient androids may have been more reality than myth. The most imposing legacies of the ancient world still stand today. But temples, palaces, and tombs of stone do not tell the full story of life hundreds and thousands of years ago. If we look deeper beneath the ruins, we find a world of extraordinary automated machines.
Although the ancients lacked electronics and computers, some of their automata were really surprisingly sophisticated and incorporated concepts like feedback control and programming.
We are discovering that the ability to create programmable gadgets has been around for 2 millennia. There existed automated devices that were centuries ahead of their time. And many of the breakthrough innovations gave birth to the science of robotics and to the technologies we still use in automated machines today.
A lot of people think that robotics was invented at the beginning of the 20th century. But there were proto-robots. There were a lot of proto-robots around throughout the centuries for 2,000 years, and without those we wouldn't have any modern robots.
The human imagination has always dreamed of a future where we might interact with life-size human replicants. But unbelievably, this might not be a dream. Could it have happened hundreds of years ago? Vinci is a small town nestled in the Italian hills. It might have remained an insignificant dot on the map were it not for one man, the town's most famous son, Leonardo da Vinci. Leonardo was a genius in his own time. He created some of the most amazing inventions one man has ever produced, and many of his concepts changed the world. The Leonardo Museum in Vinci contains models of some of the most important and fantastic inventions the world has ever seen. Ingenious counterweight cranes, Leonardo's prototype helicopter, the first in history, strange and claw-like wing designs for futuristic flying machines, and large tanks with heavy defenses and mounted with powerful cannons 400 years before they were first used in battle. But the museum contains treasures far more valuable than the models of his creations. The manuscripts that record the actual drawings and notes penned by the hand of Leonardo himself. The collection is known as the Codex Atlanticus. Contained within its pages are sketches and virtual blueprints for hundreds of Leonardo's inventions. Hidden among the pages of this text is an extraordinary find, one that challenges the history books. The pages describe in intriguing detail the inner workings of a fully automated android, made to look like a knight.
So now what it's left us with is having to be detectives. It's a bit like an archaeological dig. We have to go in, we have to look at the drawings over and over and over again.
Florence, Italy is where Leonardo did much of his work. Alessandra Romanelli is a curator at the Leonardo Museum in the city. It is here that robotics historians have actually reconstructed Leonardo's robot knight, based on sketches made by Leonardo himself 500 years ago.
Leonardo dedicated himself to the project of an automaton, which is a humanoid machine.
Leonardo's android was designed based on an advanced knowledge of biomechanics.
And that's the science of how our bodies move. And so he was all the time thinking about, how could I make a machine that would be like a person?
Leonardo's robot was designed to replicate human movement through metal. Muscles, tendons, and ligaments were all first studied meticulously before their function was transformed into the robot's design.
Leonardo thought of the human body as a wonderful, perfect machine, and he tried to create a mechanical model that could reproduce the effect of human movements.
cogs in the chest of the robot were attached to axles that were wound with rope. As the key cogs rotated, the rope became unwound or wound tighter. The rope was attached to the limbs, and as the rope was pulled or released, the limb moved.
It worked through the effect of tightening and loosening the ropes to simulate the traction and straining of limbs.
Beneath the knight's armor, we can see the gears and ropes that turned to tighten and loosen the ropes attached to the arms.
We can see the wheels in the robot's chest.
The ropes were fed from the cogs in the chest, through the shoulder and all the way down the arms. The result was that the turning of a gear produced a movement in the limb.
This would be the movement of the arm.
Put together, it produced a remarkably human result.
So what the robot can do is hug someone. So they reckoned it went up to people and hugged them.
The robot knight would have enthralled and entertained audiences wherever it went. But were there robots of the ancient world designed for more sinister and violent purposes? The ancient Greeks lived in an age of myth and legends, a world populated by gods and monsters. But in ancient texts, there are stories of another kind of being. This one, fully mechanical, stories of robot warriors. Homer, the most famous of ancient poets and writer of the tale of Troy, tells us of the god Hephaestus, the Greek god of smelting and metalwork.
He was the god of blacksmiths. He was the god of manufacturers. He was probably the first engineer ever on Earth.
Ancient texts say that Hephaestus lived high in the mountains of ancient Greece, and it was here he had his forge, where he smelted, beat, and created weapons, armor, and all things metal for the gods themselves. He was said to have produced countless ingenious mechanical devices, but intriguingly, Homer tells us that he also forged robots. They are described as having 3 legs and could move and operate independently, as if they were living beasts, truly ancient androids.
Many of the historical references which we read now seem to be fantastical or even ridiculous in the claims. But one of the things that becomes more apparent the more one delves into it is that there may well be a grain of truth in some of these claims.
But is the idea of real working android soldiers in the ancient world as far-fetched as we might think? The Greek myths tell of ancient supersized humanoid warriors.
A good example here is the man-robot android called Talos, who was made as a gift to the king of Crete.
Legend has it that Zeus, the supreme deity and father of the gods, gave the robot giant to the king of Crete, an island off the coast of Greece. The elite warrior was charged with defending the island against all enemies.
Talos was claimed to be able to move, was claimed to be able to fight, and was given to help defend the place.
Talos would run around the island 3 times a day and pelt invaders with large boulders. Was this the world's first robot warrior?
If anything, it was robotic in shape, but probably consisted of a person in a suit.
Whether the Talos existed or not, it is evidence of a fascinating discovery. Even if the ancient Greeks did not yet have the technological capability to build human replicants, they had taken a massive conceptual step. They strived to create machines that behave like humans. They understood that with the right technology, human robots could one day be constructed.
Most of the cultures in the ancient world had mythological references to robotic machines or robotic people. There seems to be a sort of human obsession with machines that mimic the human form or animal form. They certainly were starting to put together the ground rules of robotic machines. They understood levers, pulleys. Most of the mechanical principles that we know of today were invented in those times.
The ancients clearly understood the concept of robotics, but were they able to put theoretical principles into practice? Remarkably, it would be left to one man to fully automate the ancient world. In his lifetime, the ancients would develop automatic doors, drink dispensers, and even the same principles that drive today's motors and machines. Although we may think of robots and androids as being an invention of the 20th century, there is incredible evidence of early automated devices in antiquity. At the height of his power, Alexander the Great's empire covered much of the known world. And perhaps the jewel in the crown of his dominion was the city which still bears his name, Alexandria.
Robotics seems to have begun in ancient Alexandria around about 300 BC.
In 300 BC, Alexandria was the most vibrant intellectual city in the known world.
This occurred basically because Alexandria was set up as a city where learning was very important.
And leading the field was an inventor who can claim to be called the godfather of robotics, Heron of Alexandria.
He's the big name, and it's for one simple reason. 5 of his books are still in existence.
Heron's books are evidence of an Alexandrian society that was so advanced they became the center of learning and technological achievement throughout the known world.
Some of these early peoples were far more sophisticated than we give them credit for. They were at least as intelligent as we are now. Their mastery of philosophy, of astronomy, of what we would now call physics, was absolutely immense. So it'd be dangerous for us to underestimate their capacity.
But is there evidence that the ancients actually devised fully automated devices? The answer is yes. Recently, new discoveries dating back thousands of years now tell us that the ancients did in fact have and use advanced automated machines. Worshippers visited temples with self-opening automatic doors. Audiences flocked to automated puppet theaters, and ancient texts even tell of chariots flying through massive temples, seemingly on their own. By the 3rd century BC, the city had become an ancient technopark, where sophisticated machines played a part of everyday life. And at the center of it all was Heron. He was renowned for testing and demonstrating his theories and devices to produce wonder and entertainment.
He describes many, many different inventions that were designed to surprise and give the impression of magic.
And don't forget, he was a showman. His work was to display and make people really excited about engineering.
Alexandrian high society kept up with the latest developments in technological innovation, even at their own dinner parties. Richard Windley is an historical model maker and specialist in recreating Heron's amazing devices.
We're very fortunate in having most of the translations of Heron's treatise on pneumatics, in which he talks about air pressures, water pressures, the interaction of the two. And in his treatise, he describes a number of objects which are based around these principles. This piece is number 66, and he describes it as a vessel for dispensing a measured quantity of liquid, wine usually being the favourite.
But how does the jug measure exactly how much wine to release?
Inside the vessel is a valve which is operated by this mechanism at the top, which in turn goes down to this lever which counterbalances the cup at the front.
When Richard removes the weight, the wine starts to pour. When the cup is nearly full, the balance tips and the flow of wine stops as if by magic. But how did the dispenser work?
The heart of the system is a little valve which sits inside the bottom of the vessel. The Greeks seem to favour these little conical-shaped gravity valves because they opened and closed very quickly. The little conical weight drops into the orifice of the valve when the cup is heavy enough, and this cuts off the flow of wine from the vessel to the cup.
When the weight is removed, the bar drops under gravity. This causes the connecting rod to drop, which lifts the valve, and the fluid can flow through the conical valve and out of the jug.
Now, because the cup is balanced by the weight at the rear, as soon as it reaches a predetermined point, dictated by that weight there, the cup will then drop. That arm rises, the valve drops, cuts off the flow of liquid, and so that cycle of the process is finished. It's an absolutely fascinating design, and it's probably the first real genesis of control systems that we're aware of.
But what if a guest became carried away with the ingenuity of this technological achievement, or its wine contents? For people like these, Heron was a prankster.
This little invention proves that the ancient Greeks had both a sense of humour and a sense of mischief. It's called a greedy cup, and a host would present this to one of his guests who had perhaps a reputation for enjoying his cups. And what would happen is that when the chalice, or calyx, was partially filled with wine, it would just act as a normal cup. As soon as the guest said, no, fill it up, top up the cup, the little siphon in the centre of the cup suddenly starts to operate, and the entire contents of the cup are dumped onto the person's lap, all over the clothes of the unsuspecting guest.
Hidden within the center column of the cup is a pipe with a bend. There is an opening to this pipe at the bottom of the cup. When the liquid in the cup reaches a level higher than the bend, air pressure forces the liquid through the tube, up and around and out of the cup. The liquid continues to flow even as the level drops below the bend because of a difference in air pressure between this height and the bottom of the tube. The liquid continues to run down the tube and all over the unsuspecting guest.
An ancient practical joke.
But Heron was interested in much more than party tricks. He utilized a deceptively simple invention to fantastic effect. It is simply called the cam. As the disc rotates, the rod moves up and down. It may sound simple, but this ingenious and deceptively simple device translates circular motion into lateral motion. This allows a wheel to produce a push or a pull. Also, if used backwards, a push or a pull can be converted into circular motion. This is how the piston's movement is converted to circular movement in the camshaft of an engine. This exact principle is used in all engines, right up till the modern day. For all of Heron's brilliance, he had yet to design his masterpiece, an entire theater whose actors were robots. The modern library of Alexandria is a stunning architectural achievement. But Alexandria was a hotbed of technological innovation over 2,000 years ago. And at the cutting edge of this new wave of ingenuity and innovation was a man called Heron. Many of Heron's inventions had practical applications, but he also excelled in the art of creating mechanisms for entertainment.
Mechanical technology was also used in the service of public entertainment. Ancient audiences became increasingly sophisticated, wanted more and more visual entertainment.
One of Heron's biggest challenges was to create technologically advanced entertainment systems. One idea he dreamed of was a theater with no actors, only robots. In Dublin, Ireland, robotics and automata designer Mick Kelly has created a replica of this incredible theater.
First they'll see the theatre with the doors closed, and then the doors will open for them, and they'll see little men on the back of the stage making ships, and then hands will start to move and they'll hammer and they'll saw.
Backdrops fall into place, and actors and scenery move about the stage, all at exactly the right time. But how did Heron ensure that each event happened in the correct order? Unbelievably, all these actions are driven by a single event. When Mick pulls the release switch from a sand tube, a weight falls. This weight is attached to a camshaft that turns and pulls on strings.
And they make it revolve. And as that revolves, it pulls the other strings that are off that and winds them around it, shortening their length.
These strings are attached to pins. When these pins are released, parts of the scenery are allowed to fall under gravity. Other pins release secondary weights, which fall and pull extra strings, which move the other features around the stage. Heron's theater is a highly complex automatic machine. But what is incredible is it is also programmable.
Those strings are different lengths, and that determines when a mechanism is going to operate. So to change the length of a string will effectively program to do something else.
Amazingly, what looks like a simple toy is actually one of the first pieces of automated programmable machinery ever created by the human mind. There were two principles used by Heron in his automated machines. The first, used in machines like the theater, relied on weighted moving parts, ropes and wires and cams. But Heron invented a second breakthrough in automation, the world's first hydraulic systems.
One of Heron's favourite mechanisms appeared to be a device whereby air pressure is produced by water moving from one vessel into another. As the water runs into the vessel, the air is compressed and has to move somewhere, so it's usually piped to possibly a sound-producing or movement-producing device.
Today, this technology is known to science as pneumatics.
Pneumatics is all about the way in which air and gas move and how air and gas can be used to move things.
Heron's books clearly show an understanding of the mechanics of air.
He knew the air had substance, it had volume, it was made of particles, and if you pushed it, it would have to go somewhere, and if you sucked it, it would come with you.
But could Heron apply these theories to the real world? An opportunity arose when he was challenged to create a garden of birds that could move and sing in the total absence of humans, or birds.
We have reports from visitors to the Byzantine court of numerous mechanical devices, one of which was a tree which contained metallic singing birds. The model works on the basis of water falling from one vessel to another, displacing the air and blowing a series of small water warblers which are contained within the birds.
The water enters the system through the lion's mouth and drops into a bowl. From there, it runs down into the next vessel below, which is a sealed container. So as the water rushes in, the air in the container is forced out, along the tubes and out of the mouths of the warblers, where there are whistles to make the noise.
When that container becomes full, it then siphons suddenly into the lower container. And as that fills, the weight of that vessel actually operates the owl, which then turns to look at the birds. As that lower vessel fills up, it reaches a point almost to full and then siphons. The weight then decreases dramatically because the water's going out. The vessel then rises under the influence of the counterbalance weight, turning the owl back into its original position. This makes it a kind of loop system whereby it completes one cycle and then immediately resets itself and starts again. So as long as power is being supplied, the system will cycle continuously. And really, in a sense, this makes it perhaps a precursor of what we would now call a robotic machine.
It would have amazed an audience who had never seen metal recreations of nature moving and making sounds independently of life.
Motivation behind most of these pieces was to create awe and a sense of mystery and to accentuate the power, the wealth and the technical expertise of the culture.
Heron was a master engineer. He was a master craftsman. He made things happen. He saw the opportunity and he put it together to the limit of the fabrication methods available to them at the time.
Heron was truly a giant in the field of early advances in robotics and automated machines. But he was standing on the shoulders of a giant himself, Philon of Byzantium. Philon is responsible for setting in motion many of the ideas used by Heron and inventors throughout history, right up till the present day. Like many of today's inventors, Philon was called upon to create automatic machines that would make his benefactors money. Religion played an intrinsic part in life in ancient Alexandria, and it was important that the worshippers be pure before entering the temples where they believed their gods actually lived. How could the worshippers ensure there would be a ready supply of soap and water at the temple to purify themselves? And could the priests capitalize on this demand to gain revenue for their holy places?
This device is called Philon's automatic soap dispensing machine, and it works like this. On the side of the machine is a coin slot here, which would have collected money from worshippers visiting the temple.
The coin lands in a pan on one end of a lever. The weight causes this end to go down. The other end of the lever pulls upwards and releases a valve that allows water to flow.
So when a coin was placed in there, a supply of water would be turned on. And as the vessel filled up, the weight of the vessel would act on a counterbalance shaft.
The weight of the full pot turns wheels that are attached to strings. The strings pull open the doors to the machine and at the same time cause a hand to lower,
which presents the worshipper with a ball of soap, or in this case, pumice.
The hand returns to the interior of the machine and is automatically reloaded with soap.
After a few seconds, the vessel reaches its siphon point and it dumps the water in a fairly continuous stream for several seconds down through the device, through the pipe in the lion's mouth, thus allowing the worshipper to actually wash their hands using the pumice ball. These examples of technology designed by Philon are some of the very earliest machines that we could truly call automatic. For a device which is something like 2,250 years old, this is just mind-blowing. It's a staggering achievement.
The exact same principles of this machine still drive many of our machines today, nearly 2,500 years later.
One could argue that this device was the forerunner of the modern soap dispensers that you find in washrooms.
Philon, Heron, and others in the Alexandrian school created the world's prototype robots and automated machines. Machines that self-regulate. Machines that always do the same thing time after time. And there was a special need for exactly this capability in ancient China. The ancient Chinese were impressive long-range traders, map makers, and adventurers. But it was important to them that they always knew which was home, and especially in which direction lay the fabulous holy city and capital of their empire, Beijing. How could the ancient Chinese inventors solve the problem of always being sure in which direction lay their capital? The answer lay in a high-tech chariot mounted with a programmable direction finder.
At all times, the figure which was mounted on top of the chariot would point to the capital city.
Ludo Verheyen of MTE Studios has reconstructed a full-scale model of this fascinating machine.
Yeah, this project was indeed quite a challenge. It was the first time that these features have been reconstructed ever, and the mechanics involved was really a challenge.
As Ludo rotates the device, we can see that the statue on the top always points the same way, whichever way the chariot turns. But how does it work?
It's a highly sophisticated geared mechanism which is very, very similar to the device that we find in almost every modern car, which we would now call a differential gear. The gearbox effectively is measuring the speed between two wheels. As one wheel moves faster than the other, as it does when turning a corner, it alters the position of the figure which is mounted above the chariot.
When the cart turns to the right-hand wheel turns a cog inside the machine. This turns the central gear which rotates the figure. Because the right-hand gear has rotated more than the left, the figure is turned more toward the left. So as the cart turns right, the figure turns left to compensate. The result is it seems that the pointing statue has not turned at all and always points in the same direction.
No matter where the chariot moves, how it twists and turns, the figure should always remain pointing in the same direction.
All the Chinese travelers would have to do is orientate the statue on departure, and it would remain pointing in that direction for the entire duration of the journey.
To all intents and purposes, I think it would be fair to claim that this is a robotic device. It was an incredibly important invention and has had a huge impact on the technology of the last 100 years in particular.
But there is intriguing evidence that the ancients designed machines that could perform several actions all at the same time. Could the world's first supercomputer have been designed almost 1,000 years ago? The science of robotics was surprisingly advanced in the ancient world. But how were their machines powered?
If you go back 2,000 years, they didn't have batteries, they didn't have electrical outlets, and this was a real problem for them.
One of the most reliable sources of energy in the ancient world was water. And one of the most complex water-driven automata was a forerunner of today's synthesizer organs. Rodney Briscoe is fascinated by these ancient machines.
The water rises in the top of the tank here, where it falls through these tubes. You get a vortex and it sucks in air. So you get a mixture of air and water then descending into the tank at the bottom, where the water would pass out and the air pressure would then be transferred to the organ. And the air passes up into the wind chamber here, where the cylinder turns. It's operated by the water wheel, by the same water from the tank at the top. It opens the valves and lets the air through into the pipes, and the pipes play. Let's try it.
In ancient times, they would have used a waterfall. Today, we are simulating the effect of water falling under gravity using an electric pump.
The water is now entering the top chamber and falling down into the system below to create the air, and it's now turning the wheel and making the music, just as it would have done thousands of years ago.
Pins on the rotating drum lift levers that open the valves and allow the air into the pipes. But there was a machine in the ancient world that used water not for power, where water was the central part of the mechanics itself. At the temple in Karnak, an intriguing find was discovered during a major excavation.
They came upon a huge cache of statues that had been buried at some point in antiquity. And among these statues was a very interesting artifact. It was an alabaster jar dated by inscription to the reign of Amenhotep III. And that's about 3,000 years ago.
Although this incredibly ancient find may look like a simple container, it would be useless for storing any liquids. The pot has a built-in leak.
Water would be put into the jar and would flow out at a controlled rate. And this served as a timing device.
Small holes down the sides of the urn indicate how much water has escaped. All the priest would have to do is examine how full the pot was, and they could tell how much time had passed since the clock was filled. It is the ancient world's first water clock. But is there evidence from the ancient world of technically advanced clocks that kept time permanently? Clocks that were fully automated. The search begins in the 400-year-old library of St. John's College in Oxford, England. Here, there are writings that are over 1,000 years old. Dr. Emily Savage Smith from the Oxford University Department of Oriental Studies is researching an ancient inventor, robotics engineer, and clockmaker. His name is Al-Jazari.
Al-Jazari, in 1206, composed a treatise on ingenious mechanical devices, in which he described roughly 50 devices in great detail.
The Topkapi Library in Istanbul, Turkey, amazingly still contains copies of this ancient manuscript. Within its pages are contained some of the most important breakthroughs in engineering the world has ever known, written by Al-Jazari himself.
He's important because it happens that his is the only treatise that we have preserved today that does this.
Al-Jazari was part of a new wave of Middle Eastern inventors. Inventors that understood the importance of the Alexandrian proto-robot designers that had come before.
They had obviously read Heron of Alexandria, and we know that it was translated in Baghdad at that time.
Building on the innovations of the Alexandrians, Al-Jazari created one of the ancient world's most complex and impressive automated machines designed to keep time. In the Ibn Battuta Mall in Dubai, ancient historians have created a model of this impressive machine. It is known as the castle clock. At regular intervals throughout the day, the clock performs certain specific actions. Signs of the zodiac rotate around the top of the clock. A moon travels along the top, opening doors to show the passing hours. Falcons drop a ball every half an hour, and every hour, the robot musicians play. Behind the clock, we can see the ingenious arrangement of mechanics that drive this sophisticated series of events. Water drains out of a vertical tube under gravity. In this barrel is a float that lowers with the height of the water. This pulls a rope which rotates the disc, giving the signs of the zodiac. This rope also pulls a trolley to which is attached the crescent moon, which moves along the front. And rods on the trolley activate the opening of the doors exactly as the moon passes. As the trolley passes set points, it releases balls that run down a tube and out of a falcon's mouth into the bowl. Meanwhile, the water that was draining from the vertical tube runs into a basin. When this reaches its siphon point, it rushes out past a water wheel. This water wheel is attached to a camshaft. Cams on the shaft knock on levers attached to the musicians at the front, who move and play. Amazingly, it was said that the clock kept very accurate time, hundreds of years before clockwork and the harnessing of electricity or the use of servos. But there is an even more intriguing element of the clock. In the medieval Islamic world, the day was divided into 12 hours between sunrise and sunset. This meant, as the days got longer in summer or shorter in winter, the clock would have to be reprogrammed to a different length of hour. This would be done every day, making Al-Jazari's castle clock truly one of the world's first programmable supercomputers.
Al-Jazari can be regarded as the person who invented the first robot.
Yet for all of the advancement of the ancients, there remains one amazing invention that stands apart: a fully automated, self-propelled, ancient programmable robot. The concept of the robot captures the human imagination. The idea of artificial pets, servants, warriors, or entertainers has enthralled human beings since records began. But is there evidence that the engineers of the ancient world were creating exactly this type of robot hundreds of years ago? Is it possible that there were artificial humans and animals in antiquity?
Throughout Chinese history, there have been stories of magical and fantastical machines that imitated human figures doing all sorts of activities. And the little gadget I've got here is actually of a serving girl, and the idea is that she will carry a glass of wine or drink to one of the guests at the dinner table.
The model performs a predetermined circuit of the table. This ancient android is powered by a coiled spring that is wound by the operator, exactly the same way we might wind a watch or clock today. This spring drives a large central cog. The central cog is connected to several other smaller cogs, each with their own function. It is the complicated and sophisticated interaction of these smaller cogs that produces the range of movements that the girl performs. An amazing achievement hundreds of years before the complex machines of the European Industrial Revolution.
We should not be surprised that the ancients had robotic technology. They were not fools. They had mechanism, they had power, they had vision.
But the T-girl always repeats the same moves. To really see a self-propelled automatic programmable robot, we must turn to the most famous inventor in history, Leonardo da Vinci. Could Leonardo really have created a self-propelled, fully programmable robot? Remarkably, ancient texts tell us that 500 years ago, during an official ceremony, Leonardo presented a stunning gift to the King of France.
And we know for sure the King of France once witnessed the robot because it was a big celebration.
As onlookers watched in amazement, a lion walked with no wires or any help or interaction across the floor of the throne room.
And it came out to the King of France, opened its chest and gave him flowers, and everybody was stunned.
Today, using modern technological research, might it be possible to reconstruct Leonardo's lion? The challenge is monumental. Leonardo's blueprints of the robot lion have been lost to history.
After Leonardo died, his manuscripts got spread everywhere. Lots of them got lost, about 2/3 of them, and lots of others got cut up and put in different pages.
At a robot laboratory in Florence, Italy, Leonardo robot expert Laura Stiatesi works with the latest in computer modeling software.
The biggest problem was to produce a lion that had a range of movements, but furthermore, that all these movements would be powered by springs, without the aid of any motor or electrical input whatsoever.
Also on the team is ancient robotics expert Luca Garai. In a 300-year-old library in Bologna, Italy, Luca is trying to piece together the clues in Leonardo's sketches and discover the mechanisms within the lion that made it programmable.
The first person to actually program mechanisms was Leonardo during the Renaissance. He drew on some ideas from the Arabs and maybe the Chinese via the Arabs. But he was the very first to actually create a programmable machine.
The historians will have to search through the remnants of what evidence Leonardo left us and use all their powers of deduction. Might robotics specialists, historians, and model makers be able to decode the sketches in the Codex Atlanticus? To recreate the first fully automated programmable ancient robot using only ideas set out by Leonardo himself.
We were very determined not to use any modern technologies or to take any shortcuts that were not available back then.
Using only technologies understood by Leonardo, the researchers create this beautiful reconstruction, a complete replica of the world's first ever fully programmable robot. Moving under its own power, this replica of an ancient robot lion walks across the floor, exactly as it had when Leonardo presented it over 500 years ago. But how did the researchers ensure that the lion would perform its functions correctly and in time? The researchers discover that all the lion's functions are driven by a central drum. This gets its motive power from a coiled spring that must be wound up. This component drives several hundred individual cogs, each with its own function. One group might move the head, another the chest, but how would they set the timings of each function? Leonardo would have employed a technique known as gear ratios that is still used in modern machines today. For every turn of the main drive, other cogs turn faster, depending on their size. A cog half the size turns twice as fast. By programming the ratios between the large central cog and all the others, the operator would be able to set how many turns each cog made in relation to another. This would enable them to set the timing of each individual action and program the movement of the lion, exactly as Leonardo would have done 500 years ago.
The feelings that everyone who worked on the project had were similar to what it must be like for a mother to see her child walk for the first time. The satisfaction of seeing a machine powered by its own internal mechanics with no auxiliary power, petrol, or electricity was incredible.
It is amazing to think that before batteries, electronic power sources, and computers, the ancients were creating programmable robots at this level of sophistication.
I'm really impressed by the incredible skill of the early people. I mean, they did the real development.
From the proto-robots of Alexandria to the technological wizardry of Leonardo da Vinci, we are finally understanding the history of robotics.
The genesis of machines goes way back, at least 2,000 years, to the Greeks, and probably a lot longer with the Chinese.
We have really precise engineering, but we wouldn't have that precise engineering without the crude engineering prototypes that were created by the geniuses of the past.
Today, we believe that we invented the machines that power our way of life. But is that true? Hydraulics, advanced machines, and the world's first androids were all part of everyday life in the ancient world. What still remains to be discovered, and what we will have to one day acknowledge, is that our claims to invention are thousands of years too late.